Hey guys, I've started to develop these videos in which we take a look at variations of different mathematical ideologies pertaining to the ACT and SAT. And in this case, we're going to be talking about ellipse equations. So I've pulled 7 questions from the ACT exams in which ellipse questions have been the focus. And you'll get to see different variations in this particular video. And it should be good enough for you to tackle any of the ellipse problems in future exams. So I'm hoping this will really help you. Second of all, one of our purposes, besides what I'm doing here, is trying to reach young adults who do not have any help outside of school. So if you would please like, share, and subscribe to the channel, and hopefully we'll find those young adults who need our help, or they can find us, that is. Now, before we can move on with this ellipse video, we need to take a look at some background information that I think is really vital for you to understand before looking at the questions. So let's get started. All righty. So the ideology of an ellipse is, we got a circle. And if you take that circle and pull in opposite directions, it will elongate like so. And that makes an elliptical figure. Now, that elliptical figure has circle properties to it and ellipse properties to it. So we have a ratio, a mathematical ratio. Okay. Now, this ellipse can be drawn on a coordinate plane. I'm going to put 2 coordinate planes here. Y and X, Y and X. Okay, and let's call this coordinate plane number 1. Call this coordinate plane number 2. Now, it's not a perfect ellipse drawing because I'm no Picasso, but I need to give you some background information on it. Now, notice the ellipse in figure 1 here is stretched out along the x-axis. So it's longer than it is wide. We're going to call this axis now the major axis. Now, the y-axis is shorter than it is long. So we're going to call that y-axis the minor axis. Okay, so these places on the ellipse have specific names. This is A, this is negative A, this is B, this here is negative B. Now there are 2 points close to the ends that I'm going to draw with a star, and they're called C. Now these starred positions are called foci. Now the equation that describes figure 1, the standard form of the ellipse equation, has a circle portion of it in the numerator, so it's going to be x squared and then y squared. The ellipse portion of it is in the denominator, and since the a values, the major axis is associated with the x-axis of the coordinate plane, the a values are going to be associated with the x here. So we're going to call that a squared. The b values, or the minor axis, is associated with the y-axis, so we're going to call that b squared. Now what I'm going to do is I'm going to draw just the opposite on figure 2. All right, here's our a, here's our minus a, here's our b, here's our minus b, and our foci will be like right about here. Okay, so that'll be our c and c. Now, the formula associated with figure 2 is just changed in the denominator. We still have x squared in the numerator. Now, our a's are associated with the y-axis. That's our major axis now. So we're going to put a squared here. And our b's are associated with the x-axis, or our minor axis. We're going to put b squared here. Now, note the difference in the equations based on how the ellipse is oriented on the graph. Okay, now, there's one other equation that's important, and you need to know how to calculate the foci. So to calculate the foci, we're going to say c squared is equal to a squared minus b squared. So the major minus the minor. I'm going to show you how to use all these equations in the problems that are coming up. Okay, let's move on to the problems. So we have an ellipse that is elongated around the y-axis. So our major is going to be the y-axis, and our minor is going to be associated with the x-axis. It says, which of the following ordered pairs are the foci of the ellipse? All right, so here's what we have. We have the equation x minus 3 squared, y minus 5 squared, 9, and then 25, and that's equal to 1. Now, the center of the ellipse is going to be really important. And the way we're going to get the center of the ellipse is we're going to look at the numerator, the circle portion of it. And if you remember, what we have in the numerator relates to the circle. So that's the standard form of the circle equation in the numerator up here. So we got x minus 3, so that 3 is the h value, and the 5 is the k value. Let me change colors. We're going to put our center of the circle right here at 3, 5. So 3, 5. That's the center. When we calculate the foci, the y value, the 5, the center of the circle, is going to be very important to help us find the foci. And the foci are going to be somewhere up in this area. And what we're going to do is make the calculation to get that determined. All right. So remember, the equation for the foci is c squared is equal to a squared minus b squared. In this case, we know the major axis is the y-axis, and so we know the 25 is our a value, or our a squared value, I should say. And that leaves 9 as our b squared value. Now 25 minus 9 is 16. So that's equal to c squared. That's c squared. We need c. So c is going to be equal to the square root of 16, which is equal to plus and minus 4. All right, so this plus and minus 4 is going to be really important. We're going to need the center of the circle, our 3, 5. And remember, just a minute ago, I told you the 5 is going to be really important because our foci are on the major axis. So we're going to need the y value of 5, the center of the circle. We're going to say 5 plus 4 is equal to 9. And then 5 minus 4 is equal to 1. There are our y values of our coordinate pairs. So the x value is going to remain the same. So we're going to have 3, 1, and then 3, 9. That's our foci coordinate pairs, 3, 9 and 3, 1. And that's going to give us answer choice D as in dog. All right. Let's go to the next one. Now, as soon as you look at the image, you see there's a large circle, you see there's an ellipse within the large circle, and you see there's a small circle within the ellipse. So let's look at the information they give us. They say show below in the standard coordinate plane 2 circles and 1 ellipse. And it's centered at 0, 0. The larger circle has the equation x squared plus y squared is equal to 25. Okay, so let me do this, change my pen tip. So the larger circle is x squared plus y squared is equal to 25. Well, remember that's x squared plus y squared is equal to r squared. So the radius of the large circle is going to be a 5. That's the radius. Now, the other one is x squared plus y squared is equal to 4. So the small circle radius is going to be a 2. Okay. Now, it goes on and says, which of the following equations represents the ellipse? So we know right here is the radius of the large one, that's a 5. And we know right here is the radius of the small one, that's a 2. Now, the ellipse is stretched out around the x-axis. So therefore, our equation is going to look like this. Let me change my pen tip. X squared over a squared plus y squared over b squared is equal to 1. So this is going to be x squared over 5 squared plus y squared over 2 squared is equal to 1. Let's clean it up. X squared over 25 plus y squared over 4 is equal to 1. So there's our equation for the ellipse. And that's going to be answer choice D as in dog. All right, let's move on. So here's an interesting one. Shown below is a quadrilateral ABCD inscribed in an ellipse. The figure will be placed in the standard coordinate plane, and the ellipse will be described by the equation x squared over 9 plus y minus 5 squared over 16 is equal to 1. Given that line segment AC is the minor axis and BD is the major axis, what will be the coordinate points of A and B? Okay, so in the numerator, there's no H value with our X. So therefore, the center of the ellipse is going to be a 0, 5. So up here, right here, let me change my pen tip. The center is going to be on the y-axis at 5, 0, 5. So 0, 5. If I were to sketch this, or what I could do, well, it'd be better if I just sketch it. If I were to sketch this, let me sketch it right here. One, 2, 3, 4, 5, and then it's going to continue to go up, right? So 1, 2, 3, 4, 5. Here's our 5. This is where the center would be. It's hard for me to draw that on top of the figure. Now we know A is out here somewhere, and then we know B is up here at the top somewhere. Okay. The next thing that we need to look at, we know the minor axis is associated with the X value. Now, this 9 was actually 3 squared. This 16 is actually 4 squared. So therefore, our B value, or our point A value, is going to be a -3 over here on this side. Now we're at 0, 5, and we've got to go 4 more places up on the y-axis. That's going to take us to 9. So 5 plus our 4 takes us to 9. And so we're going to have 0, 9, and then -3, 5. So point A is -3, 5. B is 0, 9. That's going to be answer choice J. Let's go to the next one. Which of the following equations determines the ellipse? Well, we know in this case, the major axis is with the y value. So that's going to be our a squared term. The minor axis is along the x-axis. That's our b squared term. When you look at the y-axis, you see the y value of 7. So that a value is 7. And the b value is a 4. Now, let's clean this up. It's going to be x squared over 16 plus y squared over 49 is equal to 1. That's going to give us answer choice C on that paper. On that paper, on the figure, sorry. Now they could have left it. Let's call this step 1, step 2, step 3. Technically, they could have left it like we have it in step 2. So be on the lookout for that. Most of the time, you're going to see it like I've got it in step 3, though. All right, let's go on. Now it says, which of the following equations determines the ellipse in the coordinate plane? All right, now notice there isn't the standard form of the ellipse equation written in our answer choices. So we're going to have to manipulate this in just a minute to figure this out. We know the major axis is around the x. So that means we're going to have something like x squared over, and that's a 5 squared. And the minor axis is the y, which gives us a 3. And that's going to be 3 squared. So here we're going to have x squared over 25 plus y squared over 9 is equal to 1. Now we got to convert this standard form into the form that we see in our answer choices there. So think about this as just adding two fractions together. So we need a common denominator, right? So we're going to multiply x squared over 25 by 9 over 9. And then we're going to multiply y squared over 9 by 25 over 25. All right. So that's going to give us 9x squared over 225. Plus 25y squared over 225. Now we can rewrite this and say 9x squared over 9x squared plus, 25y squared all over 225 is equal to 1. You can multiply it. Now, on the left side, just a minute ago, I multiplied by 9 and 25. That gives me 225, so I have to multiply the right by that. So I'm going to take and move my denominator to the right side, and I'm going to get 9x squared plus 25y squared is equal to 225. And that's going to give us answer choice C. Okay, 2 more. All right, so this one is just moved down to around the 4th quadrant of the graph. So let me get my red pen. It says one of the following equations represents the ellipse. Which one? Well, we know that the center of the ellipse is going to be right here. That's going to give us a 2 and a -3. Oh, that looks bad. Let me fix this. Let me put it down here. So the center is going to be at 2, -3. Okay. So we know where that is. And notice our y value at the bottom of the ellipse is going x distance to -8. So we're at -3, and we need to get to -8. So from there to there is going to be 5 units, right? And notice we need to go up to a 2. So we're going to go 5 units from -3 up to 2. Okay. So with that being said, and one other thing, we know we're going over to -1 and then 5 from the center. So that's going to give us a distance of 3. So therefore, our equation, now I'll remind you that the major is around the y-axis. Let me get my pen change color. So our equation is going to be set up like this. The major's around the y-axis, so b is going to be with the x value. And a squared is going to be with the y value. Now our b value is 3. And our a value is 5. So that's going to be x squared over 9 plus y squared over 25. It's going to be equal to 1. Now we need something in here with a 9 and a 25. And D and E fit that profile. However, we need to compensate the numerator of this standard form of ellipse equation because of where the center is of our circle. So remember, the standard form for the circle is x minus h squared plus y minus k squared is equal to r squared. Okay, so notice on our image, the center of our circle is at 2 and -3. So our x value or our h value will be x minus 2 squared plus y plus 3 squared. And it's plus because the 3 is a negative. And when you take y minus a -3, in this case, you get y plus 3. Hence, that's why this is here. So therefore, our final equation will look like this: x minus 2 squared over 9 plus y plus 3 squared over 25 is equal to 1. And that's going to give us answer choice D. Now look at E. Look at the signs. You see how the signs are different in the numerators? Be very careful with those signs. Okay, now I've put this problem here because I want you to learn how to use your graphing calculator. You probably already know how to do that. In this case, instead of drawing the graph and having to plot everything to make 2 different graphs on the same coordinate plane, it's easier if you will just insert both of these equations into your calculator and then graph them together. And what you will find, they do not intersect anywhere. So the answer is going to be F. And I encourage you to do that because knowing how to use your calculator on this test is really important. Sometimes you don't have time to work everything out long-handed. And so you need to be able to use that calculator efficiently and accurately so that you don't make any mistakes with it. And that's why I'm leaving this one for you to graph on your own. Okay, I hope this has been helpful to you. And whenever you guys are planning to take your ACT, I wish you all the best. And please remember to help us help those young people who don't have any access to help outside of school. So please like and share and subscribe to our channel. I would really appreciate it. And together we can also help them. So good luck on your test, and I wish you all the best.